Morning, all of you. Am I audible for you? Good morning. Am I audible for you? Kindly respond. One of you can respond.
Yes, sir.
Thank you. So in the last class, we were talking about co-channel interference. Co-channel means the cells which are sharing the same channel. Okay. So if these cells are not sufficiently far apart from each other, then there is high possibility of interference to take place. Okay. Co-channel means they are sharing the same frequency bandwidth. So they should be separated from each other. Okay. So since because of our limited capacity or limited bandwidth, if we are forced to place these cells very much close to each other, still there is high possibility of interference. Today we'll be discussing about adjacent channel interference. From the name itself, it's evident that adjacent channel interference is nothing but the interference that is caused between two channels which are very close to each other. Okay, maybe the two cells are close to each other, but these two cells are assigned a set of channels which are continuous in bandwidth. Okay, maybe they are not, I mean, the bandwidth will be different, but even though the bandwidth is different, these bandwidth assigned to each consecutive cells, they will be continuous in nature. Means the bandwidth are very close to each other. The frequencies are more than it is somewhat it is similar. Okay, so because of similar frequencies, what will happen is the receiver filters will not be able to tune to the exact frequency what it is being desired. So unwanted frequencies from the adjacent channel will also penetrate into its receiver filters, and after all, the effect is crosstalk, which means some background noise will be always there along with the intended message signal. Okay, so the adjacent channel interference is caused because of undesired or because of minimum separation between the channels. So how we can minimize adjacent channel interference? By increasing the separation between the channels, provided if the channels are very much close to each other in terms of their frequency allotted. Okay, understood. If the two channels are having some bandwidth and if the bandwidth are very close to each other, then what's happening? Unwanted frequencies will be penetrating into the receiver filters. So whatever we have desired, along with that particular message, what we desired, some background crosstalk will also penetrate. This is because of interference that's caused by adjacent channel, which is making use of somewhat similar frequencies, not exact frequencies, but very close frequencies. So how we can minimize this effect, or how we can minimize this adjacent channel interference, is that by having a separation between the channels. So if the separation or the frequency separation between the channel is maximized, then we can minimize the adjacent channel interference. Means some guard band is to be allocated. Okay. Suppose I have allocated a definite bandwidth to a particular cell, then another cell which is close to my cell should be allocated a different frequency band such that the one that is being allotted previously, it should be much far from the new frequencies that is allocated to the neighboring cell. So between these two bandwidth, there should be some gap. Okay, there should be some frequency separation so that we can minimize the adjacent channel interference. If interference is minimized, then what will happen? Filtering will be effective. Okay, filtering can be made more careful. Okay, that is, receivers will be able to receive the only intended frequencies, only the intended messages which is of desirable frequencies. So all the unwanted frequencies of the neighboring channel will get eliminated because of strength, because of the property or the effectiveness of the filtering. So this can be minimized, or adjacent channel interference can be minimized only if sufficient frequency separation is being imparted between the two channels which are very close of frequencies. Okay, in terms of frequency, they may be close to each other, but what should we do is we should allocate the frequencies or bandwidth to the two cells in such a way that it should be very far apart from each other, or there should be some gap in between the two bandwidth. Clear? So this can be more clear by looking into this example. I'll show you. See, in this example, you have a cluster which is composed of 7 cells. Okay, you know what is a cluster? Cluster is nothing but a set of cells. there will be a definite number of cells which will be having a set of channels allocated to a definite number of subscribers. Okay, these cluster will be replicated n number of times so as to accommodate the entire service area or entire geographical area to provide service to all the subscribers present in the node. So as we can see here, we are having sorry, 3 plus 3 plus 1, yeah, 7 number of cells. So the cluster size is nothing but n is equal to 7. And here in the upper side, it is being shown, there are 14 sets of bandwidth. As you have here, 14 sets of bandwidth is being provided. Okay, one means it is one set of bandwidth or one set of frequencies that will be allocated to one cell, and two means it is a second bandwidth or which is continuous to one. Third is a third bandwidth which is continuous to two. Like that, you have 14 set of bandwidth which is to be allocated to this available number of cells in the cluster. And since we are having only 7 cells which is replicating again and again among the entire geographical region, what we can do is we can assign 2 channels or 2 bandwidth per cell. Isn't it? We can assign 2 sets of frequency bands to one cell. So that 7 into 2 will become 40. Is that clear for you? Suppose a spectrum is having 14 sets of bands or 14 number of bandwidth you have. Okay, which are very continuous in nature, or the frequency allocated to all these channels, it is continuous in nature. There is no gap in between. So what we can do is, our objective is to minimize the adjacent channel interference. So for that, what we must do, we should allocate these each bands in such a way that there should be enough separation between 2 adjacent channels. Okay, so what we can do is here, consider cell number A. Okay, consider this cell number A, which is labeled as A. To this cell, what I have done is I have allocated the frequency band 1 as well as 8. Okay, so we have allocated 2 channels to one cell. So that 7 into 2 will become 14 sets of frequency bands. So all these 14 sets of frequency bands or 14 channels will be allocated to the entire cells available in the particular cluster so that we can use this entire spectrum effectively. So here when we concentrate in cell number A, you can see the channel number 1 and channel number 8 is allocated to cell number A such that these 2 channels are 7 channels apart from each other. Isn't it? The 2 channels that is allocated to cell number A, okay, the cell labeled A is 7 channel apart. So we can say that the 8th channel whose bandwidth is very much separable from first channel. So there is no possibility of adjacent channel interference. You know that adjacent channel interference will come into excess if the frequency bands are very close to each other. So in that sense, some sort of frequencies will leak into the pass band. So that should not happen. So to minimize this adjacent channel interference, what we need to do is we need to separate the available channels to a cell which is very far apart from each other. Okay, there should be a bandwidth separation or frequency separation between the 2 channels. As you can see here, channel number 1 and channel number 8 allocated to cell number A is 7 channels apart. Means there is sufficient frequency separation between the 2 channels so that we can minimize the interference. And when you consider cell number B, here we have allocated channel 2 to that. Okay, if you are taking cell number B, we have allocated second channel to B, and after 7th separation, we'll have the 9th channel also allocated to B. So from this figure, it is understood that you are allocating 2 channels per cells. So if you are allocating 2 means the second channel will be 9th channel. So that there exists 7 separations between the 2 adjacent channels. So there will be a minimum chance of interference. Similarly, when you take the cell number C, okay, you have taken 5th channel. Okay, you have allocated the 5th channel to cell number C. Similarly, after 7 separations, you will be allocating the 12th channel to cell number C so that there is sufficient frequency separation between the 2 channels. So there is minimum possibility of adjacent channel interference. So in this way, we need to assign the channel from the available set of channels, whatever we have. I repeat, suppose spectrum is having 14 channels with us and we need to redistribute these 14 channels among the available cells, and we have capital N equal to 7. What do you mean by capital N? What do you mean by capital N? Capital N is cluster size. That is, in cluster we'll have 7 cells. So if we are distributing this equally, means one cell will have two channels. So what we are doing is we are not allocating continuous channels to each cell. For example, if you take cell number 1, if we take cell number 1, we are not doing, or we are not allocating 1 and 2, because what happens if 1 and 2 is allocated simultaneously, or but that is continuously to channel number A, then we see that the two channels are very close to each other, and there will be some possibility of frequency leakage from one channel to another channel. As a result, there will be some crosstalk or interference as the background. So that should not take place here. Okay, so what we can do is, to cell number A, if we assign first channel, okay, suppose the first channel is assigned to cell number A, then we will have a 7 separations, and then we will take the 8th channel also to A. Okay, so that there is sufficient frequency separation between 1 and 8, so that there is minimum adjacent channel interference. Is that clear for you? So in this way, we can reduce the adjacent channel interference by proper frequency planning or channel assignment strategies. So there are two types of interference as we discussed. One is co-channel and the second one is adjacent channel interference, and we know how to minimize these interferences. Okay, adjacent channel interference can be minimized by properly planning the frequencies or separating the frequencies. We are not allocating continuous channels to the same cells. If you are allocating continuous frequencies to the same channel, means then there exists a frequency leakage which should not take place, or which is undesirable. For that only we are imparting the frequency separation. Now coming to the next topic. Any doubts? Any doubts with respect to this particular example of channel assignment strategy of adjacent channel interference? Now the next module is, the next topic is trunking. Trunking. So in this topic, you will be dealing with the concept of trunking, then some of the key parameters of traffic theory. Traffic means nothing but the subscribers. Okay, the subscribers that are active in one particular observation period. So we'll be dealing with key definitions or the terminologies. Then we'll deal with the concept of airline. That is measurement. Traffic can be measured by using a unit called airline. Okay, airline is the unit of measuring the traffic intensity in telecommunication systems. Then quality of a network or quality of a telecommunication network can be measured in terms of a term called grade of service. Then we will discuss about two types of trunked system and the concept of trunking efficiency. So these are all the learning objective of this particular topic. The topic name is trunking. Clear? Now, what do you mean by trunking? Why we go for trunking? So the main objective of trunking is to accommodate large number of users in a limited radio spectrum. That is, we have limited spectrum with us, and our objective is to allocate maximum number of subscribers within the available spectrum. So for that only we are using the concept of trunking. And what do you mean by trunking? That is, we will have an available pool of channels. So from this pool of available channels, we will take a few set of channels and allocate to the subscribers upon their request. Subscribers, with the help of this MSC and base station, they will request the service, and to offer the service, what we'll do is, or what the server will do is, or what the trunked system will do is, the trunked radio system will allocate a set of channels from the pool of channels to these subscribers. So once a subscriber finishes its service, then these channels will be returned back to the pool. It is not that permanently that particular channel is available to the entire subscriber. Okay, so whenever a channel is available as free, then that channel, provided if it comes under the particular cluster or under that particular cell, then that will be allocated to the subscriber. So there will be a pool of channels allocated to the entire cell. Okay, so if a subscriber is under the base station of that particular cell, and if he put a request on a call, okay, if he put a request for a service, then what this MSC or base station will do is, they will allocate a set of channel to that particular subscriber. So channels in the sense, it can be voice channel or control channel. Both can be. Okay, there should be necessity of control channel as well as voice channel for the user to provide the service. Okay, so once that call is being terminated or the conversation is finished, what will happen? The channel will be ultimately returned back to the pool. So that depends upon the status of the channel, whether the channel is busy or not. Okay, so in a trunked radio system, each user is allocated a channel on a per cell basis. Means for a particular cell, we'll have a set of channels allocated. Upon termination of the call, that is, after the conversation, the previously occupied channel is immediately returned to the pool of the available channel because they need to offer the service for newly incoming calls. Okay, so upon the termination of the call, the allocated channels will get back into the pool and they will be waiting for the new customers or new incoming calls which are waiting for the service. Okay, so this is a concept of trunking. Trunking is nothing but the process of allocating a set of channels for a subscriber upon their request. And after the termination of the particular call, the channel is returned back to the pool. Is the concept is clear? And why we are go for trunking? Because we are having limited number of channels or limited spectrum. So these channels have to be shared among different users in one cell. Okay, we can't confine the channel to a particular subscriber for indefinite time. It has to be shared. Okay, so whenever a subscriber is terminating a call, then there is no use of allocating the same channel to that particular subscriber for indefinite time, isn't it? It has to be allocated for some other users which are requesting the call. Now, the thing is that at all time, the server will not be able to provide the channel to the subscribers because whenever a subscriber is requesting a call in the busy hour means like the peak hour or the peak traffic hour like office times, then there can be some situations where all the available channels in the pool are busy. Then the server won't be able to, or the mobile switching center, it won't be able to provide a service to the new subscriber because all the channels are now in the busy stage. They are in the service. Okay, other calls are in progress. So in that particular situation, a call can be blocked or it can be delayed. So that measurement of quality or the measurement of probability of blocking a channel, that is nothing but it can be measured by terms of grade of service. So grade of service is nothing but a parameter that measures the quality of the entire telecommunication system. Whether a call can be, that is in terms of the probability of a call to get blocked. Okay, so it is a quality measurement parameter, that is what is known as grade of service. And the concept of trunking is nothing but the allotment of channels from the available set of channels in the pool. After the termination of that particular call, the channel will get back into the pool and it will be waiting for another new call which is offering request to the system. Hope it is clear. Any doubts with respect to trunking, the concept of trunking? In the earlier ancient times and all, that is, if the calling subscriber or the called subscriber is in a foreign country, then he has to book this trunked call before 2 weeks and all, isn't it? Because the available number of channels is very few in number. So he has to wait for 2 weeks and 3 weeks. He will be booking the call in a trunked channel, and then only after booking, he has to wait for 2 to 3 weeks, and then only he will be able to that is establish the conversation with the called subscriber. Okay, nowadays the spectrum has developed more, or we are having more number of channels, but still during peak busy hours and all, there can be situations where no channels can be allocated to a particular subscriber. So in that case, the call can experience a block or delay. That is measured in terms of grade of service. Any doubts, students? Is that clear for you? Kindly respond, one of you.
Clear.
Okay. Now we'll go for some important terminologies in this particular domain. The first term is setup time. You know what is setup time? It is a time required to allocate a radio channel to a requesting user. For example, a user has requested a call, but there exists some time to allocate the channels to that user. Maybe it is not instantly available. All the available channels in the pool are now in the busy state. So in that case, the user has to wait for definite time until the channel is being allocated to him. That is what is called setup time. Next one is blocked call. I told you during the peak busy hour and all, the call will get congested because of heavy traffic. Because of heavy traffic, all the calls, all the channels are in the busy state. They are currently in, serving. They are currently busy in serving other calls. So what will happen is that a call which cannot be completed at the time of request, that is known as lost call or blocked call because of the congestion. Due to congestion in the system or because of the non-availability of the channels in the pool, a call can get there is a chance for that particular call to get blocked. And finally, it will lost. Holding time means average duration of a typical call. Means after his request, the radio channels will be allocated to the subscriber, and the called subscriber and calling subscriber now will start the conversation between each other. And during this particular time, we can say that now call is on hold. Okay, so holding time is nothing but the duration of a particular call. It will be denoted as capital H. Normally, it will be measured in seconds. It depends upon the question. If it is minutes, hours also, it is okay. Okay, so H is nothing but the holding time. So all these notations and parameters are important for you because we need to solve the numericals with respect to this particular topic. So kindly see all these notations. Holding time is represented by capital H. Next is request rate. Request rate or arrival rate means how many number of average calls request per unit time. That is, if you take 1 second as the base time, in the particular 1 second, how many number of calls is requested or it is being arrived to the system. That is known as request rate. It is represented by lambda. For example, if lambda is equal to 3, it means that 3 calls have been arrived in per unit of time or per second. 3 requests has been came to the server, so that the server is responsible for offering the service. He need to allocate the channels, available channels from the pool of channels. That is what is called a trunking. And based upon that, he will give service to all the subscribers. If all the available channels are busy, means that particular call will not be able to get the service. He will be in a blocked state, and continuous blocking will lead to lost call. Next, fifth parameter is traffic intensity. It is measured by capital A, and I told you the intensity of a traffic is measured in terms of airline. Here, what traffic we are dealing with? We are dealing with the traffic of telecommunication system. Okay, so here the concept of traffic intensity should be very clear for you. It is a measure of channel time utilization or the average channel occupancy measured in airlines. Suppose you consider one channel. Okay, consider the case of one channel, and if that particular channel is always occupied for the entire duration. Okay, consider that 1 hour is the entire observation period. So during that entire 1 hour, assume that that particular channel is busy. Then the traffic intensity is 1 airline. This means 10% that particular channel is occupied for the entire duration. I repeat, you have 1 hour as the observation period to observe a particular channel. Okay, and this particular channel is busy for that entire duration. The call has not been terminated at all, which means that the channel is busy for the entire duration, and hence we can say that the traffic intensity of that particular channel is 1 erlang. Clear? So it is measured in terms of channel occupancy. If the channel is free for the entire period, then it is 0 erlang. Okay. So with respect to one channel, I am talking, not with respect to all entire system. Okay, with respect to one channel or one user, you can say that the maximum value of traffic intensity will be 1 and the minimum will be 0. But you will not find all in all cases it will be within 1 and all. There can be certain situations when it is greater than 1. So that will come when you are taking the entire system into account or the entire channels into account. I'm talking about one channel in this particular case. That is, if the particular entire channel is occupied for the all the duration or all the observation interval, then we can say that the traffic intensity of that channel is 1 airline. Suppose you have 60 minutes of observation interval. Out of that 60 minutes, 30 minutes is busy. The channel is busy in providing service to a customer. Then the remaining 30 minutes, the channel is free. In that case, the traffic intensity of the channel is 0.5 Erlang, half 0.5 Erlang. Clear? If it is 20 by 60, then it is 1 by 3 is the traffic intensity. 1 by 3 Erlang is the traffic intensity. Clear? Of 60 minutes, 20 minutes is occupied, remaining 40 minutes it is left free. Then in that case, the traffic intensity is 1 by 3. So we can say that the traffic intensity is measured in terms of occupancy of channel, average channel occupancy. Now, what do you mean by load? Load is nothing but traffic intensity across the entire TRS. Here also it is measured in terms of airlines, but we can't say that here it is one airline because we are taking the entire TRS into account. What do you mean by TRS? Trunked radio system. Means we are going to consider the all channels available in the pool. All set of channels available in the pools into consideration, and then we are measuring the total traffic intensity. That is what is called as load. It is also measured in terms of airlines. Its unit is also airlines. So don't confuse with the traffic intensity and load. Traffic intensity is something which is measured in terms of channel utilization time or occupancy time, whereas load, while measuring the load, we need to consider the entire traffic intensity of the radio system into account. What do you mean by TRS? TRS is the short form of trunked radio system. Here, hope you got the concept of all these 6 terminologies: setup time, blocked call, holding call, request rate, traffic intensity, and load. Any doubts? Any doubts? Please ask.
No, sir.
Okay. So as I told you, Erlang is nothing but the unit of traffic. So it is named after the founder, the scientist who has developed this theory, a Danish mathematician who has developed this trunking theory in telecommunication system. So it was named after his invention or after his search. So Erlang is a unit of telecommunications traffic measurement, and it represents the continuous use of one voice path. If the entire voice path is continuously used for all the available observation period, then we can say that the traffic intensity is 1 Erlang. Okay. Or it is used to describe the total traffic volume of 1 hour. In 1 hour, how much traffic volume is accommodated by the system. That is also measured by Erlang. This is what is for one channel. This is very important. The last thing, for one channel, the minimum load is 0 Erlang. For maximum load is 1 Erlang. This is only for one channel, I repeat. In numerical questions and all, you will find the parameter of Erlang as more than 1. It means that it is not for one single channel. If it is for one single channel, then the minimum value of traffic intensity is 0 Erlang. Means 0 Erlang means the entire time duration it is free. For the entire available observation period, the channel is free, which means that the load is 0. If it is 1 Erlang, it means that 100% the particular channel is utilized, 100% time for the entire observation time that is being occupied. Then it is called 1 Erlang. So this parameter or these minimum and maximum values applicable only for one channel. Please note it. If number of channels is more, n equal to 5, 10, 15 and all, this concept will not hold good. Understood? There is another example I have shown here, a radio channel that is occupied for 30 minutes, means 30 by 60. Then we can say that the traffic carried by the system is 0.5 Erlang. Traffic carried by that particular channel is 0.5 Erlang. Because I'm considering only one channel in that particular system. So when we are measuring the traffic intensity per channel, then we can say that the maximum load will be 1 Erlang and minimum load will be 0 Erlang, because we are measuring it in terms of the time occupancy of the channel. Now take down this example, another example. Kindly take down this, take your notes, don't sit idle. Example is if a group of 100 users made 30 calls. Totally, we have 100 users or 100 customers in one cell, and they are making 30 calls. That is remaining 70 are idle. Only 30 calls are in progress in 1 hour. Okay, so the observation time interval is 1 hour. 1 hour is nothing but 60 minutes. And each call had an average call duration. What is call duration? It is holding time. How you will, what is the notation of holding time? What is the notation of holding time? It is capital H. So the average holding time, that is capital H, is equal to 5 minutes. So for each call, the duration is 5 minutes. So that what is the total duration of the entire calls in the particular system? Totally, there are how many calls? We are having 30 calls. So the traffic duration of all the calls will be 30 into 5, that is 150. Okay. So the total hours or the total minutes that is busy in the particular system is 30 into 5, that is 150. Now, how many or what is the observation period that you have? It is 60. So 150 by 60, that is equal to 2.5 airline. So here the traffic intensity is 2.5. That is why I told you here we have consider the entire users, all the 100 users, that is the entire channels that's available in the system. In the earlier example, I consider only one channel. In that case, the minimum load will be 0 airline and maximum will be 1 airline. But here I have taken all the 30 calls into consideration simultaneously. So that 30 into 5 will become 150 minutes. So out of 1 hour, 150 minutes is occupied. So 150 divided by 60. 1 hour means 60. So 150 by 60 is 2.5. So the traffic intensity is 2.5 airlines. So hope you got the difference between this traffic intensity and the previous one. The previous one, there we have considered only one single channel, but here I didn't mention any per channel system. I didn't mention any channels here. Here you have considered the 100 number of users, and out of 100 number of users, you have taken 30 calls as in progress, and based upon that, you have calculated the traffic intensity. Whereas in the previous case, that is measured in terms of per channel basis. The intensity measured in per channel basis means it will be confined to from 0 to 1 airline. While on the other case, if you are taking all users into consideration and then measuring the traffic intensity of the entire system, then it can be more than 1, because the observation time will be very less and the holding time, average holding time for all the users will be very large. So numerator by denominator, if the numerator is greater than denominator, then the traffic intensity is very large. Clear? Any doubts? Kindly take down this example. Now, few more definitions you have, because you need to do all these definitions. You need to have the concept behind these definitions, and only you will be able to do the numerical problems. So the first concept is traffic intensity offered by each user. AU. AU under that is A subscript U. You have U with the subscript. It means it's a traffic intensity per user. Okay. So in that case, what you have to do is to find AU, you need to multiply lambda with H. You know what is lambda? Lambda is the request rate or call arrival rate. What do you mean by call arrival rate? What do you mean by call arrival rate? Anybody? What is call arrival rate? It is the number of calls arrived per unit of time, isn't it? So you need to get that number of calls. So what you need to do, you need to multiply with the holding time. Then that is nothing but the traffic intensity offered by each user, that is per user basis. From one user, what is the traffic intensity that is offered? For that, we need to multiply the call arrival rate with holding time. Its unit is also airlines. Now, if we want to measure the total offer traffic intensity, what we have to do? Total offer traffic intensity means we need to consider the entire users. In the first point, we are going to consider only one user as such. But here, while measuring the total offered traffic intensity, what you need to do is you need to measure the traffic that is coming from you users. How many users are there? There are u number of users. So you need to multiply the parameter u with AU, whatever you had found out earlier. Okay, so in the first point, you have found out AU by multiplying lambda and H. Lambda is the arrival rate and H is the holding time. After finding AU, what you have done is you have multiplied that AU with the capital U so that you will get the total offer traffic. So don't get confused with AU and U. If the AU and A, okay, if you have a notation U along with A, it means that this is offer traffic intensity per user. This is a total offer traffic intensity while considering all the users in the system. Next is we are going for per channel basis. That is traffic intensity per channel. What you will do? After finding A, we need to divide by C. Okay. As of now, we have A with us. What is A? A is the total offer traffic intensity. So once you have the total offer traffic intensity with you, then you need to divide the parameter with the capital C. Capital C is the total channels available in the system. So if you divide the C with A, what is A? A is U into AU. So U into AU divided by C. After dividing this with capital C, you will get the traffic intensity per channel. So these notations you have to study. You should not confuse with these three things. AU is the traffic intensity per user. A is the total offer traffic intensity while considering all the users, and AC is the traffic intensity per channel. If we are measuring in per channel basis, then we need to divide the total traffic intensity divided by number of channels available in the system. Clear? Any doubts? Any doubts behind the theoretical concept of these three parameters? AU, A and AC. AU equal to lambda into H. Lambda is arrival rate. Arrival rate is nothing but number of calls that is arrived per unit of time. H is the holding time. Holding time means average, in an average, how much duration a call is in hold. Okay. So that we need to multiply so that you will get AU. That is offer traffic from one user. To find all the offer traffic intensity, you need to multiply AU with U. U is the number of users in the system. If you need to find the traffic intensity in per channel basis, then you need to divide that U into AU divided by C, where C is the total number of trunked channels available in the TRS. What is TRS? TRS is trunked radio system. See, in another 1 minute, this meeting will get an end, so you can relog in with the same link again. Now, going to grade of service. So already we had the concept of trunking. Now, I told you